Today's Ergo360 tutorial will update users first on the automatic autofill process we've developed, which takes information from the flight plan and inserts it into the app automatically. First, let's open Ergo360 and notice the username and passwords are filled in automatically. Select the Login button, and this will advance to the Confirm Recall number. Normally, the last flight plan filed in the ADS database will be displayed here, and the user needs to confirm this number matches the flight plan recall number that's being used for this flight. Touching the white area recall entry box will open a drop-down menu where other flight plans may be used to enter data into the Ergo360 program. The next tab, Show Oxygen Etp Flight Plan, if selected, will open the ADS flight plan for review. This flight plan uses information from the actual ETP analysis from the flight planning provider, as well as oxygen information specifics to this user's aircraft from the ADS oxygen database. To return to the login sequence, press the iPad home button and then go back to the Ergo360 icon, and now we can press Submit. Confirm data. The confirmed data entry window should be reviewed by both pilots and that all data is confirmed to be correct. Once this is done, select Submit to advance to the Visual Flight Plan Verification window, where the pilots can visually see the results of tabulated calculations provided by the flight planning company. The confirmed data entry window should be reviewed by both pilots and that all data is confirmed to be correct. Once this is done, select Submit to advance to the Visual Flight Plan Verification window, where the pilots can visually see the results of the tabulated calculations provided by the flight planning company in ADS. The pilots merely need to ensure that the fuel and oxygen range rings extend past the required diversion airports. Once confirmed, pushing Submit will complete the automatic login process using flight plan data fed to the Ergo360 app, and you are ready now to go flying. This display will show the calculated fuel and oxygen rings around the current location of the app's GPS position, which, by the way, is the same as selecting actual mode from the bottom menu. Using the app in conjunction with the flight plan makes this entire process less than a minute to set up, and you're ready to go. These instructions were used in Ergo360 automation, where flight plan information has been uploaded into the app and the user need only to confirm the data is correct. Next, we'll use the app in the manual mode, where information is inserted into each individual entry box. To do so, to disconnect the automation when we open the app, we must first deselect the ADS ETP button found in the Settings tab and then log out. In this tutorial, we'll demonstrate the use of Ergo360 and explain the individual tab functions along the bottom menu. First, open the app up to the Login menu and then select Login. The Start Ergo tab found in the lower left-hand corner and the init process entry box are the same. They're synonymous, and this is the first step for data entry. First, let's open the oxygen units window and select which metrics is to be used for the flight for the aircraft being flown. This app will allow the user to select PSI, liters remaining, or percentage of full. For this example, we'll select PSI. The next window will display which aircraft will be used for this flight. Once the aircraft is known to Ergo360, it will reference a fuel and oxygen database specifically for that aircraft. When the aircraft is selected, it will autofill the maximum values for the next 3 windows. Any manual input will be a number less than what is currently shown. The last 2 windows are the diversion airports found on your flight plan. If there are multiple ETPs, use the ETP with the longest diversion time, since this will have the greatest impact to the oxygen system. In this example, we'll be using Gander, Newfoundland and Shannon, Ireland as our diversion airports. Now, click Submit to advance to the Plan Mode tab. In the Plan Mode, all of this data, with the exception of the oxygen quantity, can be found in the ETP analysis of the flight plan. The first entry box, Etp Altitude, is the depressurized altitude found on the flight plan. Today, we'll make it 12,000 feet. ETP time is the time from the ETP to the diversion airport. Remember to use the longest time of all ETPs provided. ETP fuel is the fuel remaining at the ETP. It is the fuel needed to fly from the ETP to the diversion airport. Oxygen PSI is the dispatch quantity planned on departure. This will have to be supplied by the pilot or from maintenance. The last entry window, the latitude, is automatically calculated based on a great circle route between the diversion airports. Should the route actually not fly over the diversion airports, Then inserting the latitude from the longest ETP also found on your flight plan will displace the planned aircraft position visually to reflect a more accurate solution for the pilot. Now, we can advance to the actual mode. Selecting actual mode allows the pilot to enter real-time data, and it will display actual fuel and oxygen reserves around current aircraft position. For convenience, a copy from the Flight Plan Mode tab is available, and it will enter data already provided from the flight plan. Aircraft altitude. As you can see, the aircraft altitude from the flight plan is entered, but can be manually changed. No wind direction or velocity has been entered, but can be at any time. Entering the wind direction and velocity will skew the distance circles around the aircraft to provide a more realistic effect that wind will have on fuel and oxygen reserves. Fuel. The fuel on board at the ETP is also copied from the flight plan and reflected here. Total fuel flow. Fuel flow and true airspeed come from the ADS database using long-range cruise data one should expect to see based on altitude and aircraft weight. This data can be manually entered at any time in the flight. O2 quantity. Oxygen quantity is read in the flight deck instrumentation, should be entered here or updated here at any time in flight. Latitude and longitude should automatically be entered here from the iPad GPS with no input from the user. Should a manual entry be necessary, the pilot can update the latitude longitude at any time manually from another source using data from the FMS or the IRS. Once the iPad GPS position is restored, it will automatically begin updating aircraft position, and this can be reflected by observing the latitude and longitude changing on its own. Once finished, click Submit, and the app will slew back to its present position, in this instance, Teterboro. Now let's move on to Map Overlay. The 100% Fire tab will display the projected oxygen remaining in PSI as distance it can fly using a range ring on the mapping platform. The 100% mode has a higher than normal oxygen flow rate and can easily impact oxygen reserves. Manual entries can be made by touching the white area inside the entry box. Clicking Submit will display a distance range ring along with a numerical value for the pilot to use in his decision-making process. Let's clear this display and continue on to the Vessel tab. Next is the Vessel tab. Pushing the Vessel tab will display ships or maritime assets in a region defined by the diversion airports entered in the Start Ergo tab. In this example, we're looking at ships between Gander, Newfoundland and Shannon, Ireland. Ship icon size can easily be changed for improved readability. Touching a ship icon will open an information banner. The information displayed from right to left is as follows. The first value is the Z time, or universal coordinated time, that the vessel reported its last position. It does not reflect the ship's position is updated. Ships can choose when to update their position. Next is the type of ship, followed by the name of the ship. Next is the latitude and longitude. Then the track that the ship is heading towards, followed by the velocity. This last value is the distance of the ship to the aircraft icon. Just remember, the aircraft is currently sitting on the ramp in Teterboro. Next, let's talk about vessel clusters and airport clusters. This is an option for the user to improve readability. With clusters selected, the app will condense ship and airport icons under one icon in that area, and the number displayed under that icon will indicate how many ships or airports are contained in that cluster. Zooming in on this icon will decluster or separate these ships or airports. Zooming out will recompress that data. Next, let's talk about airports. Airport tabs. Clicking on this tab will display airports as colored push pins on a map. The airports are color-coded based on the length of the longest runway for that airport. Touching on the airport push pin will open an information banner displaying airport ICAO identifier, airport name, and the longest runway length at that airport. Green airport icons have a runway length greater than 6,000 feet, while red airport icons represent the longest runway, which is less than 3,000 feet. Blue airport icons are between 3,000 and 6,000 feet long. Next, let's talk about waypoints. If a flight plan has been loaded with waypoints, this function, when selected, will display waypoints along the route of flight. Oil rigs, mobile oil rigs, and remote islands are under development, and when completed will be accessible for display. Okay, next let's go to the Settings tab. Under the Settings tab, the last vessel update. This displays the date and time that the ADS server received AIS data, otherwise known as ship location data from the satellite. It's important just to let you know when the last update occurred and how fresh the information is. The next line here is internet status, and this is just a secondary verification that the internet is being used to update the ship position. The vessel mode. Vessel mode has two basic selections. They are internet position or no internet position. We use last known in the label since this is dependent on when the ship reported last. The predicted ship position uses the last known vessel track and velocity to update the ship position on the map, as well as the latitude and longitude found in the ship information banner. Remember, if the internet is being used, the ships will display blue icons. If no internet is being received or predicted is selected, the ships will display purple as they are doing now. GPS details. All this is a secondary banner you can find here at the bottom of the app, and it basically just shows you iPad GPS information. Should the iPad GPS signal stop receiving satellite information, it'll be noticed here immediately by all the information not changing. We know it's receiving data right here now because we can see the universal coordinated time changing, and you can see a shift in the data here. The view log tab next to this is for internal ADS troubleshooting only. Online maps. Online Maps is internet dependent and will provide a mapping program with great detail. If the internet is lost, the mapping program will revert back to the non-internet self-contained mapping program we have been using. This selection allows the user to select whatever display they'd like to look at. ADS O2 ETP, when selected on, will automatically transfer flight plan data that has been entered into the ADS database onto the iPad as the first selection after login has been selected in the startup phase of using Ergo360. The change recall number allows the user to select another flight plan recall number instead of the last flight plan entered into the ADS program. This change can be made upon startup in the app initialization, or it can be accessed here at any time once the app is fully opened. Starting Ergo without any input information can be accomplished by going to the Settings tab, deselecting the ADS O2 ETP, and then select Log Out. Touching the Login tab will reopen Ergo360 to the initial process page with all data boxes empty. Should you desire to return to using the app with preloaded data, return to Settings, select ADS O2 ETP, and then log out. Now, log in again, and this will bring you back to the recall window where you can upload data from a specific flight plan that we just spoke about. X-Plane GPS integration. When selected, we'll use the GPS signal from the X-Plane training platform and should only be selected on the ground and for X-Plane training only. Using this function will allow the pilot during simulator training to display X-Plane position on the iPad. Show Oxygen ETP Flight Plan. Pressing this tab will bring up a flight plan from the ETP, the equal time point, to the diversion airport and display fuel and oxygen reserves in 15-minute intervals. Pilots can enter and record data on the iPad should they not have a paper copy. Pressing the iPad home button and then pressing the iPad Ergo360 icon will return the user to Ergo360. Finally, the Sos tab down here in the lower right side of the iPad app. This function is the same as pulling a fire alarm to alert search and rescue assets that you're in distress and a water landing is imminent. This important app function allows the pilot to send out an all-call distress message at the touch of a button, reducing pilot task saturation and to resume efforts to fly the aircraft without distraction. The Sos tab has two functions. The first and most important function is a transmission of a data message that will get transmitted on a dedicated maritime data frequency to all deep water vessels. All ships receiving this transmission will sound an audio alarm on the bridge of all ships within VHF range. It also sends a text data message with pertinent aircraft information, such as the type of distress, addition in this case, time or position, to name a few. This data gets displayed and recorded on the ship's radio receiver screen, which must be reviewed by the ship's captain and bridge personnel. The next function we're going to show you is a voice distress message once the data message is sent out. The pilot will select the ship he intends to ditch alongside of by tapping on the vessel icon and opening up the information banner. A confirmation message will appear, and once OK is selected, it will begin a computer voice-generated distress message that will get broadcasted to all ships within VHF range. This message will repeat every 2.5 minutes with updated iPad information such as longitude, latitude, airspeed, time to touchdown, until the app is closed or the app stops working. Should a ship acknowledge the call, the pilot always has the option to disconnect the iPad cable from the radio and speak directly to the ship for further coordination. This incredible tool will significantly reduce pilot task saturation and time of rescue, while at the same time Expand the ditching envelope from just day VFR to landing now at night or during periods of low visibility or low ceilings conditions. No further action is required by the pilot, and now he can return to flying the aircraft. Okay, let's go ahead and we'll listen to the computer-generated distress message right now.
Mayday, mayday, mayday. This is aircraft November 800 Whiskey. We are abandoning aircraft in the vicinity of Global Coral. Repeat. We are abandoning aircraft in the vicinity of Global Coral. Position 51 degrees 2 minutes north. Tree 7 degrees 51 minutes west. At 1917 UTC requesting passenger and crew rescue. Repeat. Requesting passenger and crew rescue. Persons on board 12. Aircraft speed 0 knots. Aircraft altitude. Descending through 4 tree 2 feet 1 minutes to water landing. Over.
And that's it. Thanks for watching. For more information, please visit our website at www.adsopp.com. Have a good day.